Alright, so what I have here is heavily inspired by this Ben Eater's 8-bit breadboard computer, which I'll link some stuff to into the description, probably just this entire playlist. But what I've come up with is similar to my analog fuel injection, except this isn't analog, it's digital. This bunch of comparators and resistors here represents a parallel output analog to digital converter, apparently sometimes referred to as a flash ADC. This is just a buffer that holds that value and then puts it on these lines. Could probably get away with not having that, but just from what I've learned, it seems like a very good idea. Up here we have a counter, and the speed at which it counts is set by a 555 timer. And all of these basic logic gates here obviously would be replaced with a more integrated circuit. But all they do is make sure that all of these 8 lines and these 8 lines, each representing 8 bits, once they equal each other, whether it's a couple of zeros, whatever they are, this out here gets set, and that leads to the counter being reset to 0. This here, an SR flip-flop, keeps it from just immediately starting to count again until an ignition event, or Hall effect sensor, attack signal, whatever, which once this value gets lower so it doesn't take as long, I will click that. Set to 3. Once this counts to 3, resets. That last one doesn't stay on for the same pulse, but what we're dealing with here is if you think 0 to 100% duty cycle, that least significant bit, the last one to match, you could lose like 0.25% of accuracy. I guess if it's already 0, then you could lose a little bit more than that. There's potential for it to be higher. This is a very early rough draft, but now it's not doing anything. I mean, this counter, or this ADC, is just still reading whatever the map sensor signal would be. This thing is still pulsing the clock signal out, but the injector wouldn't be firing, because you could think of it as whenever this is high, there would be circuitry connected to that to drive an injector, and it would be off whenever this is high. Hall effect or attack, and it just starts counting. Notice how once I clicked this switch, this went back to low. Right now the injector would be firing. This is all like microseconds of what's going on right now. Could speed it up here and it'll take a little bit longer for it to count up 6 digits. And now it reset. Now it's waiting for the engine to spin back around and get a signal that it turned again. So there's no real how much per second. It's just each time the engine turns over, it sends a signal. Basic speed density. A certain amount of air goes in per cycle. It just needs to know, when does that cycle happen? When the cycle happens quicker, it gets this signal quicker. It's that simple. There. 3 of the digits. There, done. That'd be more like idle. Low vacuum, or high vacuum. Low pressure, high vacuum. There we go. Now exactly which circuits would be used, I don't know yet, but 8-bit parallel analog to digital converter, flash ADC, a potentially not needed buffer, timer, a clock for that timer. Oh, and this is adjustable too. So on the fly tuning, slow it or speed it up. It counts up quicker, so the injector's on for less. So ideally you'd have it set up to where it would run about here, and oh, it's really cold out. There's your choke. Lots of gas to get it started. As it warms up, adjust that back. Less injector. Slow and fat, fast and lean. Look how quick that counted. Slow and fat. Let this loop back around again. Max duty cycle already done because of this adjustment. There's no different tuning for idle or full throttle like on the last, the analog one, but and the great part about this is it would be easy to upgrade to be software programmable by just sticking an EEPROM right in here. The lines coming out of the buffer, the ADC here, would be the address lines, and then the lines going to these gates would be the data that's programmed on the EEPROM at that address. And whatever value this is, it spits out whatever the hell you tune it based on the reading from the map sensor. Probably should have put more of these binary to decimal displays on various parts to explain it, but yeah, it's right there. 0, 31, 127, 255. 0 through 255. That's your resolution. Instead of just 0 to 100% duty cycle, like there's your range. 8 bits. Anyway. Peace.